Usually, when we think about human perception, right, there's this implicit expectation of direct physical contact.
Right, yeah.
Like you reach out, your hand wraps around a hot ceramic mug, and you instantly feel that radiating heat against your skin.
Oh, exactly. The sensory feedback is just immediate.
It's mechanical, and it's totally undeniable. And the thing is, we instinctively treat our vision the exact same way.
Yes, we do.
You know, you look across a beautiful park, you lock eyes on, say, a red balloon tied to a bench, and your brain just tells you, without any hesitation, there it is, I am seeing it.
Yeah, that illusion of immediacy is so incredibly powerful. I mean, it literally feels like you're reaching out across the physical space of that park and grasping the balloon with your eyes.
Right.
There's no perceived delay, no sense of some medium acting between you and the object. It just feels like an instantaneous tactile connection.
But, and this is where it gets wild, the moment you ask a physicist, or maybe even more dangerously, a philosopher, to map out the actual mechanics occurring between the surface of that red rubber balloon and the photoreceptors in your eye, that clean, intuitive model just completely shatters.
Oh, it falls apart entirely.
Yeah.
Yeah.
What we think of as seeing is actually this deeply murky, complex translation of invisible energy. And to understand what you, the listener sitting here with us, are actually doing when you look at the world, you first have to answer a question that basically broke the minds of history's greatest geniuses for centuries.
Which is, what exactly is light?
Exactly, what it's like. And so, welcome to a brand new deep dive. We're thrilled you're here with us, joining as the third person at the table today.
Absolutely welcome.
Today's mission is to explore a truly fascinating intersection of hard science and deep theology. We are using a profound chapter from Ozair da Silva Mota's work, specifically Chapter 2 of his book, Analyses Biblico-Scientificus.
Right, which translates to Biblical-Scientific Analyses. And Chapter 2 specifically tackles light and vision, both in the physical and spiritual worlds.
And I want to pause here for a quick disclaimer, just to be super clear. Mota's text beautifully weaves together physical laws and Christian doctrine. Our goal on this deep dive today isn't to preach or to endorse a specific religious viewpoint.
No, not at all.
We're here to impartially explore the author's fascinating synthesis. He uses the evolution of physics, philosophy, and scripture to make some incredible points, and we're just mapping out his logic.
And his logic is rigorous. What makes Mota's work so compelling is that he treats theology with the exact same structural rigor as, like, a chemical equation.
Yeah, it's amazing.
Whether you approach this from the perspective of a strict empiricist or a theologian, watching him map the mechanical behavior of photons onto human morality is, well, it's a masterclass in interdisciplinary thinking.
He's basically using the historical evolution of physics to dissect the human soul. And to follow his map, we really have to start where human understanding started, which was completely in the dark regarding the physical essence of life.
Literally in the dark.
Right. But they were desperately trying to measure its behavior anyway. So let's go back to antiquity. If I am a scholar in ancient Greece, standing in that park, looking at that red balloon, how am I explaining the mechanism of seeing?
Well, if you're operating in, say, 300 BC, your entire framework is dictated by Euclid.
The geometry guy.
The geometry guy, exactly. The same mathematician who codified geometry in his elements also wrote this foundational treatise called Optics. And Euclid's model was built on a concept known as extramission.
Extramission. Okay, unpack that for us.
Yeah, so he theorized that vision is an active, tactile process. In his view, these visual rays actually emanate outward from the human eye, traveling through space to strike and interact with external objects.
Wait, so he thought we were basically projecting invisible tentacles out of our pupils?
Basically, yeah.
Like organic laser pointers.
Yeah, in a post-Newtonian world, that sounds completely absurd.
Right.
But neurologically, it perfectly aligns with our raw human experience.
That makes sense. I mean, when you actively direct your focus or when you try to catch someone's eye across a room.
Or when you feel the heavy weight of someone staring at you from behind.
Oh, that's such a real feeling.
Right. Vision feels like a projection of intent, not just a passive reception of data. The phenomenology of seeing absolutely supports extramission.
Okay, so the physics was completely wrong.
Ah.
Obviously, nothing is shooting out of our eyes.
No, definitely not. But the brilliance of Euclid wasn't his physical accuracy, it was his mathematical architecture. By assuming these visual emissions traveled in perfectly straight lines, Euclid was able to strip away the messy physical reality and just apply pure geometry of vision.
Wow.
He formalized perspective, he calculated angles, he mathematically proved why an object appears to shrink the further it moves away from the observer.
Because he ignored what the light was made of and focused entirely on how it behaved.
Exactly. He inaugurated an entire tradition of geometrical optics.
And it didn't end with just drawing straight lines, right?
Yeah.
I know by the 1st century AD, you get guys like Heron of Alexandria.
Yes, Heron. He starts applying this geometric logic to reflective surfaces, which is called catoptrics.
Okay.
And he actually manages to prove the law of reflection.
Which is that the angle of incidence equals the angle of reflection.
You got it.
Yeah.
And he proved it without having access to any modern calculus. His methodology is one of the most beautiful early examples of philosophical physics.
How so?
Well, he didn't just observe that light bounces off a mirror at the same angle it hits it. He actually sought an underlying natural law to explain why. Heron postulated this principle of the shortest path.
So, like, nature's efficient.
Exactly. He argued nature has an inherent economy. It doesn't waste energy or distance. Therefore, if a visual ray leaves the eye, strikes a mirror, and hits an object, it will inevitably trace the shortest possible geometric path between those points.
That is so cool. He's assuming nature has an inherent rational optimization to it. It's like this primitive echo of the principle of least action that dominates quantum physics today.
Yes, it really is. And shortly after Heron, in the 2nd century, Ptolemy takes this a step further by tackling refraction.
The bending of light.
Right. Well, we all know the classic illusion, right?
Right.
You put a straight straw into a glass of water, and it looks disjointed or broken at the surface line.
Oh, yeah.
Ptolemy actually conducted measurable empirical experiments on this. He charted pairs of angles as light moves from air into water or into glass.
That's early experimental science right there.
It is. His work represents a crucial shift toward experimental data, even if his resulting mathematical laws were, only rough approximations. It would take over a millennium for guys like Snell and Descartes to formulate the exact trigonometry of refraction.
Right.
But Ptolemy proved that the bending of light wasn't a trick of the mind. It was a predictable, mathematically governable phenomenon.
Okay, so this entire ancient era really highlights a major theme from a Mota's text. This sharp, vital distinction between the geometry of seeing how light behaves and the physics of light, what light actually is.
Yes, perfectly said. Science frequently progresses by accurately charting the behavior of a phenomenon centuries before anyone can grasp its essence.
It reminds me of early cartographers. Think about someone mapping the intricate grid of a newly discovered city by looking out from a high watchtower. They could draw the exact intersections, calculate the distances. They could tell you precisely how to navigate from point A to point B.
They had the perfect behavioral map.
Exactly. But they had absolutely no idea what the roads themselves were made of. Were they cobblestone, packed dirt, solid rock? They didn't know, and honestly, for the sake of the geometric map, it didn't really matter.
The Greeks mapped the precise traffic patterns of light without ever identifying the vehicles.
Wow, that's a great way to put it.
But, that willful ignorance regarding the physical medium couldn't last forever. The geometric harmony established in antiquity begins to fracture, like spectacularly during the scientific revolution.
Because eventually, the map isn't enough. You have to understand the material reality of the road. So when did we figure it out? When did this geometric harmony fall apart?
In the 17th century, once you get to Isaac Newton and Christian Huygens, the math just isn't enough anymore. They are looking at the exact same light, but accusing each other of fundamentally misunderstanding reality.
Let's talk about that great debate, because it's legendary. Particles versus waves.
Yeah, and the stakes of the Newton-Huygens debate cannot be overstated. This wasn't merely an academic disagreement over formulas. It was a desperate battle over ontology.
Ontology meaning the fundamental state of being, right?
Exactly. What is this stuff made of? So Newton, publishing his heavily influential Optics in 1704, championed the corpuscular theory.
Corpuscles, little particles.
Right. He posited that light was comprised of small parts or particles. To use a macro-scale analogy, he viewed a light source as like a machine gun firing microscopic, invisible particles through space.
And it makes sense why he thought that. I mean, Newton didn't just pull this out of thin air. The particle theory elegantly solved specific physical problems.
Oh, absolutely.
Like momentum. If light is a stream of physical bodies with mass, it explains why light travels in a rigid straight line in a vacuum, just like a projectile.
And it perfectly explains Heron's mirrors.
Right, the corpuscles are simply experiencing elastic collisions, physically bouncing off the glass like billiard balls.
Exactly. And crucially, it explains sharp shadows. If a stream of particles hits an opaque wall, they are physically blocked. That leaves a crisp, defined area of darkness right behind the obstacle.
Newton also had all those groundbreaking experiments with prisms, right?
Yeah, he demonstrated that white light could be split into a spectrum of colors and then recombined. He proved that color was an intrinsic property of the light itself, not something added by the glass.
That was a huge deal.
Huge. He theorized that different colors corresponded to different sizes or masses of these corpuscles, but his contemporary, Christian Huygens, found this corpuscular model deeply flawed.
So Huygens publishes his treatise on light in 1690, offering a radically different ontology. He abandons particles entirely.
Completely. Huygens argues that light is a wave. He proposes that light propagates not as discrete bullets, but as wave fronts moving through a medium.
And his mathematical model is super clever. Huygens' principle.
Right. He suggests that every single point on an advancing wavefront acts as a brand new source of a secondary spherical wave. These secondary wavelets constantly interfere and combine to push the main wave forward.
It's hard to visualize, but it solved problems Newton's particles couldn't touch.
Exactly. For instance, think about two distinct beams of light crossing paths in a dark room.
Like two flashlights shining across each other.
Yeah. They pass right through one another without any distortion whatsoever. Now, if light were a barrage of physical corpuscles, little bullets, those particles should inevitably collide, scatter, and just diffuse the beams at the intersection point.
But they don't.
They don't, but waves. Think of two ripples on the surface of a pond. They pass through each other perfectly, emerging on the other side entirely intact.
Okay, so Huygens has a really strong case. But I have to ask, why was this such a massive crisis? If they both had math that worked for different scenarios, why did the scientific community need a single, unified answer so badly?
Because if you argue that light is a wave, you are instantly obligated to answer a terrifying question. What exactly is wave?
Right, because sound is a mechanical wave of compressing air molecules.
Right.
Ocean waves are mechanical displacements of water. But we can see the light from distant stars traveling through the vast, empty vacuum of space.
Exactly the problem. If light is a wave and space is a vacuum, what is the medium?
There has to be something carrying the wave.
And this medium became the great ghost of 18th and 19th century physics. To salvage the wave theory, scientists were forced to invent a substance. They called it the luminiferous ether.
The ether. I love this part of science history because it just sounds like magic.
It basically was a mathematical magic trick. They hypothesized this invisible, massless, perfectly rigid, yet entirely frictionless fluid that permeated the entire universe. And its only purpose, its sole reason for existing, was just to provide a physical medium for light waves to vibrate through.
It was a desperate band-aid. They were trying to force the behavior of light into the familiar mechanical boxes of water and air.
And that lack of unification meant there was a profound hole in our understanding of the fabric of reality, setting up the need for a completely new scientific language field.
Which means, to solve the mystery of light, scientists actually had to look away from light entirely. They had to turn their attention to sparks and magnets and copper wires.
Which brings us to the 19th century revolution. This is the era that fundamentally rewrote the architecture of modern science. And the sequence of events is almost poetic. It starts in 1820 with a Danish physicist named Hans Christian Ørsted.
Set the scene for us. What did Ørsted do?
Well, before Ørsted, electricity and magnetism were universally considered to be completely isolated domains. Lightning was electricity. Lodestones were magnetism. There was absolutely no theoretical bridge between them.
Until he's giving a lecture, right?
Right. He's running an electrical current through a wire, and there just happens to be a magnetic compass sitting nearby. And he notices a deflection. The compass needle twitches.
Just a tiny twitch. But it changes everything.
It changes the world, because it proves that a moving electrical charge actively generates a magnetic field. The barrier between the disciplines was shattered. Electricity creates magnetism.
Okay, so if electricity creates magnetism, the obvious next question is, can magnetism create electricity?
Exactly, the inverse problem. And that fell to Michael Faraday, one of history's most brilliant experimentalists.
He was a genius in the lab.
Unbelievable intuition.
Yeah.
So Faraday hypothesized that if electricity induces magnetism, a magnet should induce an electrical current. So he sets up these meticulous experiments, but he discovers that just placing a static magnet next to a wire accomplishes absolutely nothing. The secret ingredient was flux,
Yeah.
change.
A static magnetic field does nothing.
Mhm.
But a changing magnetic field, like literally moving a magnet in and out of a coil of wire, physically pushes the electrons. It induces a current.
Yes. That discovery of electromagnetic induction is the beating heart of our entire modern civilization. Every generator, every power plant, the energy charging the device you're listening to this deep dive on right now, it all relies on Faraday's realization that you have to change the magnetic field to generate electricity.
That is wild. But Faraday, for all his experimental genius, didn't have the math, right?
Right. Faraday conceptualized these invisible lines of force wrapping around magnets and wires, but he lacked the formal mathematical training to quantify them. That task fell to James Clerk Maxwell.
The grand unifier.
Maxwell took Faraday's experimental geometries and translated them into a set of elegant, sweeping differential equations. And in doing so, Maxwell uncovered a mathematical symmetry that would resolve the mystery of light forever.
Let's unpack that aha moment, because it's so cool. He looks at the equations and realizes there's basically a perpetual engine hidden in the math.
Yes, a self-sustaining loop. If a changing electric field creates a magnetic field, and a changing magnetic field creates an electric field, they don't just act in isolation, they couple together.
They feed off each other.
Exactly. An oscillating electric field gives birth to a magnetic field, which in turn induces the next electric field, feeding off each other in this loop. This coupled, alternating energy propagates forward through space as a wave.
And because the fields generate each other, they don't need an external medium.
Boom! The fields are the medium. The luminiferous ether was instantly rendered obsolete. Maxwell proved the theoretical existence of the electromagnetic wave.
But the kicker, the ultimate mic drop in the history of theoretical physics, is when Maxwell sits down to calculate exactly how fast this self-propagating electromagnetic wave would travel.
This gives me chills every time. To find the speed of this theoretical wave, Maxwell had to use two specific numbers derived purely from laboratory experiments with static electricity and magnets.
Constants of nature.
Right. He used the permittivity of free space, basically how much resistance a vacuum offers to the formation of an electric field, and the permeability of free space, which is the vacuum's resistance to a magnetic field.
So he takes the resistance of a vacuum, plugs it into his new wave equation.
And the resulting velocity is exactly 299,792,458 meters per second.
Wow, which is the exact empirically measured speed of light, fast enough to lap the Earth 7.5 times in a single second.
It is breathtaking. Maxwell studies copper wires and magnets, calculates the tension of empty space, and the math spits out the speed of a sunbeam.
That's incredible.
The realization was profound. Light is not tiny physical projectiles, nor is it a vibration in some invisible space jelly. Light is a specific manifestation of electromagnetic radiation. Electricity, magnetism, and optics were instantly unified into a single cohesive grammar of the universe.
And Mota's text notes just how exact this is. Modern metrology literally defines the length of a meter based on its absolute universal speed limit. A meter is officially defined as the distance light travels in a vacuum in 1/299,792,458 of a second. Light is the absolute ruler for physical reality.
It is, but Maxwell's unification opens a door that is, frankly, terrifying in its scope. Because if light is just an electromagnetic wave, and these waves are defined purely by the frequency of their oscillating fields, the math dictates an infinite spectrum of waves.
Waves that we can't see.
Waves oscillating far faster or far slower than what our eyes are capable of perceiving. Maxwell's equations do not care about the biological limits of the human retina.
Right. They describe a vast, almost incomprehensible electromagnetic spectrum. Let's look at the extremes Mota analyzes. At the high energy end, you have gamma rays.
These waves oscillate with such ferocious speed that the distance between their peaks, their wavelength, is less than 10 picometers.
And to put that in perspective for you listening, a picometer is 1/trillionth of a meter. Mota points out that a gamma ray wavelength is actually smaller than the Bohr radius of a single hydrogen atom.
You have waves of energy tighter and smaller than the foundational building blocks of matter itself.
Okay, what about the other end?
On the completely opposite end of the scale, you have extremely low frequency, or ELF, radio waves. Because these oscillate so incredibly slowly, sometimes just 3 to 30 times a second, their wavelengths stretch out to staggering lengths.
How long?
A single ELF wave can have a wavelength between 10,000 and 100,000 kilometers.
A single wave peaking and troughing over a distance roughly the size of the planet Jupiter.
Exactly. So you have a spectrum spanning from subatomic vibrations to planetary scale ripples. And right in the middle of this vast, screaming universe of energy, there is a minuscule, almost laughably small sliver of bandwidth. The wavelength's roughly between 400 and 700 nanometers.
The visible window.
That is the absolute totality of what the human eye can see. It's a fraction of a percent of the actual physical reality surrounding us. The universe is saturated in radiation that we are completely blind to.
It's like having a radio dial that stretches from Earth to Jupiter, but our biology only allows us to tune into one single static-free station. Everything else either blows out the speakers or is too quiet to hear.
That's a perfect analogy. And Mota introduces a brilliant biological insight here. This extreme limitation is not a design flaw. It's not a biological failure. The 400 to 700 nanometer window is a strict biological necessity.
Because the eye isn't just a window letting light into the brain. It's a chemical reactor.
Exactly. For us to perceive light, a photon has to enter the pupil, strike the retina, and physically interact with specialized photoreceptor cells. It relies on a specific molecule called rhodopsin.
Rhodopsin.
When a photon hits rhodopsin, it causes a physical shapeshift and an isomerization from an 11-cis structure to an all-trans structure. That literal physical bending of the molecule triggers the electrical signal that travels down the optic nerve to your brain.
And that chemical reaction requires a very specific, perfectly calibrated amount of kinetic energy.
Right, because in quantum physics, a photon's energy is inversely proportional to its wavelength. Short wavelengths, like gamma rays or UV, carry massive amounts of energy.
So if our retinas were tuned to see gamma rays, the incoming photons wouldn't just trigger a gentle chemical shapeshift. They would have enough ionizing energy to violently strip electrons from atoms. They'd blast the rhodopsin molecules apart.
Yeah, they would cause severe radiation burns to the cellular tissue. High-energy waves literally destroy the biological hardware meant to receive them.
Ouch. Okay, so high energy is out.
Yeah.
But what about the long waves? The Jupiter-sized ones, or even just infrared? Why can't we see the heat radiating off a coffee mug?
The opposite failure occurs. Long waves have incredibly low photon energy. When those photons strike the retina, they simply lack the physical punch required to overcome the activation energy threshold of the rhodopsin molecule.
They can't force the chemical shapeshift.
Right. They might gently warm the tissue, but they fail to spark the electrical sequence required for vision.
Which means visible light, that tiny 400 to 700 nanometer window, is the ultimate Goldilocks zone. It's the biological habitable zone.
Right.
The photons carry just enough energy to reliably trigger the chemistry, but are gentle enough not to shred ourselves.
We are physically locked into this specific sliver of reality purely because of our biological fragility.
That is wild. And this exact physical limitation perfectly sets up Mota's upcoming spiritual metaphor.
It does. He establishes the empirical science to drive home a philosophical reality. Just as our physical biology limits us to seeing less than 1% of the electromagnetic spectrum, humanity is often entirely blind to the vast spiritual reality surrounding us.
Before we jump fully into that spiritual realm, let's do a quick breakdown of how we actually see a specific color within that tiny window. Let's go back to that red balloon in the park. How do I see red?
Well, it's a widespread misconception that the red balloon is somehow making red light. It isn't.
Right.
When the white light from the sun, which contains the entire visible spectrum combined, hits the rubber surface of the balloon, the molecular structure of the rubber acts like an energy sponge. The electrons in the rubber atoms absorb the specific frequencies of blue, green, and yellow light.
They take that energy in, but they reject the red.
Exactly. The atomic structure refuses to absorb the specific frequency of red, so the red wavelengths are bounced back, reflected away from the surface and into your eye.
So the balloon is, paradoxically, every color except red. Red is just the leftover energy it couldn't process.
Precisely. And this physical interaction introduces the critical distinction between generating light and merely reflecting it. In physics, we categorize these as primary and secondary sources.
Break those down for us.
A primary source is an active generator of photons. The sun fusing hydrogen, a campfire burning wood, the LED in a lamp, they undergo internal energetic changes to push new light into the universe.
Okay, and a secondary source?
A secondary source generates absolutely nothing. It is intrinsically dark. It only possesses the capacity to reflect the light it receives from a primary source.
Like the moon.
The ultimate astronomical example. It dominates the night sky, but is just a cold, dead rock bouncing the sun's light back to Earth. The planets, the trees, the balloon, you and I, physically, we are all strictly secondary sources.
And here's where Mota brilliantly translates the physics lab into theology. He introduces ancient biblical texts, specifically 1 John 1.5, which states, God is light, and in him is no darkness at all. He also looks at John 1.9 and Matthew 5.14.
Right. And Mota isn't suggesting these ancient authors understood wave-particle duality. He's analyzing the text as a highly sophisticated pedagogical and moral analogy.
Saying God is light is not reducing the divine to a 400 to 700 nanometer electromagnetic wave.
No, the physics perfectly mirror the spiritual intent. In Mota's mapping, God is the ultimate primary source, not a generator of physical radiation, but the generator of ultimate reality, truth, purity, life, and revelation. God is the active emitter.
And human beings, by structural design, are secondary sources. We have no inherent spiritual light of our own. Our moral purpose, much like the moon, is to align ourselves properly to reflect the light of the primary source into the surrounding darkness.
Exactly. Believers are meant to reflect God's light so others can see.
So this makes me wonder, if we are purely secondary sources, what happens when we try to generate our own light instead of reflecting the primary source? Does the text suggest we end up blinding ourselves?
Yes. The great tragedy of the human condition, according to this framework, occurs when a secondary source suffers from the delusion that it is a primary source. When a human attempts to generate their own artificial light, their own subjective truth, their own moral gravity, the resulting light is actually a profound, destructive darkness.
And Mota points to the ultimate historical example of this. A man who was utterly convinced his vision was perfect, who thought he was a blinding primary source of righteousness, while actually walking in complete darkness.
We are talking about Saul of Tarsus.
Yeah, let's analyze his story from Acts chapter 9.
Saul's psychological profile is a fascinating study in ontological mismatch. He was a highly educated, zealous religious leader, a Pharisee, fiercely intelligent, and he genuinely believed he was doing the work of God by systematically hunting down early Christians.
The text actually describes him as breathing threats and murder. He was securing warrants, arresting families.
It's the ultimate paradox of religious violence. He is defending the rigid, literal letter of the law while completely violating the spirit of the law. He's killing in the name of a God of love.
He's generating a toxic artificial light and demanding the world bow to it. And as he marches down the road to Damascus, he feels entirely justified. His physical vision is 20/20, and his moral confidence is absolute.
But then the ontology corrects itself violently. The narrative states that suddenly a blinding light from heaven flashes around him. It's Christ. Saul is physically struck to the ground.
And when he tries to stand up and open his eyes,
He realizes he is completely, totally blind. He has to be led by the hand into the city, where he sits in absolute darkness for 3 days.
that temporary physical blindness is such a potent symbol. It's an external manifestation of his internal spiritual state. Mota invokes John 9.39 here, where Jesus says, I came into this world for judgment, that those who do not see may see, and that those who see may become blind.
Saul positioned himself as the ultimate visionary of his faith, but the light exposed him as a blind man stumbling in the dark.
And then the restoration of his sight is equally symbolic. A disciple named Ananias prays for him, and the text says something like scales fell from his eyes.
His physical vision returns, but he is completely transformed. He goes from a violent persecutor to Paul the Apostle, preaching a gospel of radical grace.
The scales falling represents a fundamental shift in perception. Let's really unpack that.
Yeah.
Because when he opens his eyes in Damascus, the physical molecules of the room haven't changed, right?
Right. The clay pots are still clay.
The dust is the same dust. But how that physical reality is viewed has changed entirely. He is observing the universe under a new spectrum of light.
His habitable zone of perception expanded. Mota emphasizes that under this new light, the utility of the material world is radically reevaluated. Before the scales fell, things like money, political status, and religious prestige were his masters. They were status symbols.
After the scales fall, those exact same material realities are demoted to merely being tools. Wealth and influence are utilized to serve others and expand the kingdom. The physical world doesn't disappear, it's just subordinated to the spiritual reality. It makes me think of putting on a pair of infrared goggles for the first time in a dark forest. You flip the switch and the landscape is geometrically identical, the trees haven't moved, but suddenly you are seeing an entirely new layer of reality heat signatures, energy that was completely invisible to your naked eye.
That's a great way to think about it. Saul gained thermal vision for the soul. The transition from blindness to multispectral sight requires immense humility.
And what's really cool is that Mota isn't just writing about this from a detached academic distance. He experienced this exact same transition in his own life.
He gets very personal in the text. He details his own journey from a purely material ambition to a spiritual one. He grew up as a pastor's son, but he admits his vision was originally strictly confined to the physical bandwidth.
He wanted the high-paying career, the prestige, the international travel. He was staring intently at the red balloon, but he was only capable of seeing the rubber.
Right. But in the early 90s, he experienced his own scales-falling moment. His perception shifted. He made a profound decision to align his life with his faith. He went on to study chemistry at the Federal University of Paraná, really diving into the physical sciences.
And his newfound spiritual vision didn't cause him to reject science. It's the exact opposite. He uses his scientific knowledge not to replace God, but as an instrument to serve him. Today, he teaches over 500 students a year.
Which leads him to develop a really practical framework for the modern believer. If you accept the premise of Matthew 5.14, you are the light of the world, how do you actually live that out without becoming a blinding force like Saul was?
Mota lists 4 specific physical properties of light that must be mapped to human behavior. What's the first one?
The first is that light is unprejudiced. The sun's rays shine on plants, animals, the rich, and the poor equally. The photons don't discriminate based on the worthiness of the target.
So socially, if a believer is meant to reflect light, they can't practice selective grace. Paul the Apostle modeled this by preaching to kings and slaves alike with the exact same respect.
Exactly. True reflected light dismantles prejudice. The second property is that light is delicate.
Because there's a huge risk of shining light the wrong way. Think about the physics of a sunburn. That's light operating as a weapon.
Right, but Mota argues that true light is delicate. It touches a flower petal, it triggers photosynthesis without bruising the cellular walls. It brings life. Believers shouldn't act with harshness or hatred. You can't blast people with gamma rays and expect them to grow.
They just leave radiation burns.
Oh, okay. What's the third property? Purity. Light is pure. You can shine a high-powered flashlight into a raw sewer and it perfectly illuminates the filth. But the photons themselves are completely unaffected by the environment.
They don't absorb the odor. When you turn it off and take it home, the light doesn't smell like garbage. This is such a powerful physical metaphor. I want to reflect on this for a second because maintaining that boundary is so difficult in today's highly polarized, toxic world.
Oh, absolutely.
It's so easy to engage in a toxic digital environment and accidentally absorb the vitriol. Mota's challenge is that believers must influence their environment without absorbing its toxic elements. You have to illuminate the room without letting the darkness rewrite your internal code.
It is the ultimate test of integrity. And if you manage the first 3, you achieve the 4th property. Light is liberating. Once experienced, you don't want to go back to the dark. The light sets you free.
But this raises a glaring contradiction. If light is so wonderful, so liberating and warm, why do people fight it? Why did Saul murder people who followed it? Why is the truth often aggressively rejected?
To answer the psychology of resistance, Mota transitions to a brilliant philosophical connection. He integrates Plato's Allegory of the Cave from the Republic to explain why humanity prefers the dark.
Paint that picture for us. This setup is so visceral.
Imagine a deep subterranean cave. Inside, prisoners are chained by their necks and ankles since birth. They are entirely immobilized, forced to stare straight ahead at a blank stone wall.
Behind them is a roaring fire.
Right, and between the fire and the prisoners, people are walking by carrying statues and objects. The light from the fire casts shadows of these objects onto the wall in front of the prisoners.
And because they've been chained since birth, they've never seen the fire or the physical objects. The shadows are their absolute ultimate reality.
They build their whole society around predicting the movements of the shadows. Now imagine one of these prisoners is suddenly freed. He is dragged forcibly out of the cave and thrust into the blinding reality of the midday sun.
The immediate physical result is excruciating pain. The light blinds him.
Yes, the psychological and physical trauma is massive. He doesn't feel liberated, he feels attacked, he is angry, and his overwhelming instinct is to fight his liberator and return to the comforting, familiar darkness of the cave.
He wants his shadows back. The cave was the only habitable zone his mind had ever known. And Mota connects this philosophy back to the theological premise.
This perfectly explains why Jesus' contemporaries rejected him and why Saul initially persecuted the church. The true light doesn't just illuminate. At first, it hurts. It actively exposes the illusions we've built our lives around. Stepping out of the empire of darkness is a painful unlearning process.
It's a deeply universal physical experience. Think about walking out of a dark, 2-hour movie theater into the bright 2 o'clock afternoon sun. You squint, your eyes water, you shield your face. The sun isn't bad, but your eyes are so conditioned to the dark that the truth is physically painful to process.
Only gradually do the prisoner's eyes adjust, allowing him to see reflections, then objects, and finally the sun itself. Mota synthesizes his final charge to the reader based on this. We are secondary sources. Our job is to endure the initial pain of the light, reflect it with purity and delicacy, and help others slowly adjust their eyes so they too can leave the cave.
What a profound synthesis. Let's do a quick recap of the incredible ground we've covered on this deep dive.
We started by drawing geometric lines with Euclid, operating under the illusion of extramission.
Then we dove into the massive clashes of the scientific revolution, moving from Newton's particles to Huygens waves, and finally to the electromagnetic fields with Maxwell.
We discovered the strict biological constraints of our vision, locked in the 400 to 700 nanometer habitable zone.
And then we used all of that rigorous science to decode the profound spiritual journeys of the Apostle Paul, the author Ozair de Silva Mota himself, and the chained prisoners of Plato's cave.
It's been a phenomenal mapping of physical light to spiritual illumination.
And that leaves us with one final lingering thought. A question I want you listening right now to really mull over on your own. We learned earlier that our physical eyes are biologically limited to a tiny habitable zone of the electromagnetic spectrum. We are completely blind to the giant radio waves and tiny gamma rays passing through our bodies right now.
We are blind to 99% of the physical universe.
Exactly. So ask yourself, if our physical biology limits us to seeing less than 1% of the physical universe, what habitable zone is your mind currently stuck in? What massive spiritual realities are passing right through you every single day, just waiting for you to adjust your frequency to finally see them? Are you willing to endure the pain of stepping out into the sun?
That's the ultimate question.
Thank you so much for joining us on this deep dive. Keep reflecting, keep seeking the light, and never settle for just the shadows on the wall.